Welcome. I wanted to make a quick little video explaining question number 7 out of section 5.4, and the question is right here. We wish to find or to test the following claim. We have the null hypothesis, p sub 1 is equal to p sub 2, and the alternate hypothesis, p sub 1 is less than p sub 2. We're testing it at a significance level of alpha equals 0.05, and then we have some important data right here. You obtain a 5.1% successes in a sample n sub 1 of 390 from the first population. You obtain 7% successes in a sample of n sub 2, 674 from the second population. For this test, you should not use the continuancy correction. We haven't talked about that. You don't need to worry about it. You should use the normal distribution as an approximation for the binomial distribution. So this question has a couple of key points, or key things that we need to know. And so I'm going to just copy and paste really quickly a couple of formulas in. The first one here, when we're dealing with two proportions, we need to find the pooled proportion, and we need it so that we can find the standard error. And I'm just bringing these in because I feel like if I write them, it might take a little time and they might be a little bit choppy. These are from your formula sheet. And so if you notice here, kind of tracking through the question, the first thing we're really given is alpha equals 0.05. And then we have p sub 1 and p sub 2. And so I'll try to kind of organize this a little bit. How I might, you're more than welcome to do it how it works for you. But organizing the questions is sort of a big part of this one. So this is the probability of success of the first one, the probability of success of the second one, and we write these as decimals, 0.7 here. And then next up we have n sub 1 is 390, n sub 2, 674. Okay. Now we need to find the test statistic. We'll use that to find the p-value, make a decision, and then, we'll use the p-value to help us make a decision here. And eventually, if we were doing all the parts, we'd write a conclusion here. Now, if we notice, the pooled probability needs x sub 1 and x sub 2, and we have the probability of success and the number of trials. So we need to find x sub 1 here. And to do that, we just take the probability of success and multiply by the number of trials. Now you're sort of given different information in each case here on these types of questions, and so you have to make sure that you use that to find the correct information here of what you need. So I'm multiplying these cells together. I guess it might be a little bit more useful if I just typed in the values here for you to see that, but we started this way, so I'll just keep rolling with it. So the first thing I need to do is find p sub c, and that's the pooled probability. And this is the sum of the successes, so x sub 1 plus x sub 2 divided by the total number, the total sample here. So right here we're using this, x sub 1 plus x sub 2 over n sub 1 plus n sub 2. And we see these, we kind of interchange variables as far as it might be p sub a or p sub 1, something like that. So we'll have to use that to make a bit of an adjustment here. So once I have the pooled probability, I can use it to find the standard error. So our standard error here is the square root of, and we've got this whole thing here, p sub 1 times 1 minus p sub 1. We really want the pooled probability of success and then failures. Now Excel doesn't always understand that when we have parentheses we need to multiply, so we're just telling it that, and then we have 1 over n sub 1 plus 1 over n sub 2. Close that, and then close the thing for the square root. If you have some trouble with this part and you get a reference error, it means you did something that Excel doesn't understand, like maybe there wasn't a multiplication there or something of that nature. So from here, we have one more formula that we need to use, and we need to find the test statistic. To do that, we actually take p sub 1 minus p sub 2, and we want to divide that by our standard error. So I'm going to grab these unrounded p sub 1 minus p sub 2, which I guess we were given those, and then divide by our standard error here. And I'm just grabbing that. And this gives us a z-score. That's another one on our formula sheet here. I didn't copy that one over. So this is our test statistic, and so this gives us this value right here. Zooming out a little bit there so you can see. And we can use this to figure out our p-value. Now I've kind of harped on drawing a picture here. Oops. So I already had it clicked, so I don't need to grab it again, maybe. So our test statistic is, oops, not the best one, but it might be as good as it gets. Oh, okay. Well, not sure. Uh-oh. Well, we'll see here if we can draw it again. I am not sure what's happening here. We'll try another color. There we go. Get it faded out. Okay, so our test statistic is negative, so if we have our distribution, it's going to be somewhere over here. Maybe grab the black pen. Negative 1.2288. Ooh, okay. A little bit of font issue here. But what we can see, we are doing a left-tailed test. If I go up to my alternate hypothesis, maybe. This is left-tailed. And so we're looking to find this area to the left here for our p-value. So stop the drawing here. So the area to the left, remember proportions are normal distributions, or at least the ones we're dealing with right now. I'll put in the z-score and then just hit true because that gives me the area up to and including, and so this is my p-value. Now depending on the circumstances, we have to be clever with our p-value, or clever in finding it here. We usually round these to 4 decimal places, so 1096 would be the value of the p-value. And then it comes to answering these questions. So if I go back here, best of luck maybe. Our p-value here, 0.1096, is greater than our alpha, so we would kind of check this box here. If it's greater than our alpha, that means we do not reject the null hypothesis, or we fail to reject the null hypothesis. And so there we go. I hope that helps with this type of question. They do take a bit of work, and there's a lot of organizing to it. And I like to use Excel so that I don't have to do any rounding. So anyway, hope that helps. Look forward to providing more content later. Thanks.